Hello folks, I'm Ed Overstreet and welcome to the Night Sky Imaging YouTube channel. We're going to be working on Andromeda M31 that was taken, I think the second day in September, maybe the first, but irrelevant. But I'm going to be processing it. It's a mono camera. The ASI 1600 mm cooled camera, and I'm going to use, I did use the LRGB filters from Astronomic, and so let's head over there and take a look at Andromeda. Okay, I'm not there yet. Let's find PixInsight. And I'm going to open, I saved what work I had already completed on Andromeda as a project. So I'm going to load the project. And it should take me, nope, it's taking me to Sombrero. So we want to go, we're in 2022, we want to go to September. Here we go, and there's the M31 project. Now it will load everything that I had on my desktop. My process icons that I used, and absolutely everything that I had done to date, which is just awesome because being able to save as a project allows you to work on your image, and some processes take a long time and it may take you a couple days or even longer to complete your project. So being able to save it and open it back up to where you left it is super cool. Now I'm going to bring up the script, move a couple of windows around that you can't see, but I'm going to bring up the batch processing script, weighted batch processing, so that I can show you, hopefully it will populate the script with the Andromeda files, which was the last time I used the weighted batch processing was with Andromeda. So I did not use bias frames. Instead, I used flat darks, and I had 4.48 second flat darks. I'm not sure what that matched up with my flats. There's 4.5, and there's now this is an 8-second. Actually, I had 4.5 as a exposure for two of the colors. So two of the flats had the same exposure. You'll see that in a minute when we head over to calibration. But I took some 8-second darks because I had some 8-second subs lights that I use for stars only. And also I might use the core of the 8-second exposures to blend in with the longer exposures if it's blown out too much. Then I have 30-second darks for the luminance, which was shot at 30 seconds, and then the RGB were shot at 45 seconds. So I have darks for 45 seconds. And in order to populate all those, it isn't as complicated as it might look. You can go to Files or you can go to Darks, but you can click on Files, and we'll want to go to the having a navigation problem here. Okay, these are my calibration files, and just go over here and grab the I don't need the narrowband, but I did need the green, and so these are the 4.5 second greens, and these are the 4.5 second red. So the greens and the reds had the same exposure. And these are the 4.48 second flat darks for the excuse me, for the, I guess, the blues, and these are for the, so just grab all of those, and then there's my 8 seconds, and there's a 30, and there's a 45. So it was very easy. I could just go here and grab this 45 and go down to right here, and that represented all of my darks that I needed. Just so happens they're in order, and I can grab them all at one time. So you load your darks and you load your flats, and I shot flats when I shot the night of calibration files for oxygen, S2, HA, and here are the flats for the RGB and L. So you just grab all of those and you would load those in. So, and I have, so here are my flats, and here are my lights. I have 8 second blue, 8 second red, and 8 second green. There's 45 seconds, there's 8 seconds green, there's 45 seconds for the RGB, and 30 seconds for the L, and then there's the 8 seconds for the red, and 45 seconds for the RGB. So we've got everything we need loaded, and if we go over to calibration, we see where we have our our blue flats are going to match over here with our blue. They're going to calibrate with our blue lights, and so are both our 8 seconds and our 45. And we have our flat darks, and they match up with our exposures for our flats. So everything is looking good here. We ran Cosmetic Correction. Let me go back to lights. We selected drizzle, and because we are drizzling this rig. This rig is a very undersampled rig, and drizzling is a must, and I'll show you in a minute why. Also under calibration, if you click on any one of the subs, we ran Cosmetic Correction here, and I have a template up here for Cosmetic Correction that I set up. If you're curious as to how to do that, I've got videos on it somewhere in this mess of videos I've done. This isn't a one-shot color camera, so there's no need to tick the color filter array. I saved to a directory, and the directory is right here. I named the folder 1 PixInsight, and I gave it the numerical 1 name because I may run this again, and I'll call that one 2 dash PixInsight. That would be the second run of the weighted batch processing script. And the reason I might run it again, I might find another set of, I may decide to go take some hydrogen alpha, which I wish I would have had time to have done because Andromeda needs some HA, but I didn't. So that would be my second run of the script. Let's see, is there anything else we need to look at here? Everything else is at defaults. No bias, darks, flats, lights. And if, for the record, you do not put your flat darks in the bias. You just put your flat darks in the darks. They're darks. Shot at the flat exposure for the appropriate filter. and it's used instead of a bias to subtract the electronic signature from your camera. So we can look at the diagram and of what's going to happen with the lights. We're going to create a master dark in the calibration process. It's going to be an 8-second dark, master dark, for my 8-second light. And then we're going to use a master flat that's going to come from the blue 4.48 second, and that's going to be created by subtracting the master flat dark at 4.48. So we're removing the electronic signature. Now if I had shot bias, we would have subtracted bias from, let's show you. So we're going to take the flat and we're going to subtract. Well, it doesn't show you the flat dark. I wish it would. The flat dark from this to get your calibrated flat. Okay, let's see. Everything else is autos set. I'll let PixInsight pick the reference frame. And I'm puzzled as to why, because this should show the master dark being subtracted. Want to look into that later. Huh. I've got a question to send my mentor Adam Block. Alrighty. I don't know the answer to a question that I haven't even posed yet, but this calibration diagram should show the flat having the flat dark subtracted from it to get to your calibrated flat. So now the question I have is that going to take place? And so I don't know. I will find out and I will let you know. All right. Under post calibration, you can see that the integration time is 4 hours and 9 minutes. I took 100 frames of red, green, and then if you remember when I acquired this data, I forgot to tick the blue sequence or event, and so during the sequence it just didn't take blue. I had plenty of time to do it. I just didn't. So the next night I had only one objective, and that was to take the blue and calibration frames, but clouds didn't let me get 100 blues in. I got 55, and the rest of it is pretty much what I intended to get. So the only I did want to shoot just for stars, and I got 20 each of RGB. There's no need to have luminance for your stars, but I did want some color stars that weren't oversaturated, and I wanted a core that I might be able to use at a much faster exposure than the one that I used, which is pretty quick really for the galaxy itself. So then I just clicked run, and it gave me an understanding really of how much space I was going to need on my hard drive, and it said I had plenty. So I went ahead and ran it. Now, when I was done, I ended up getting these files to work on. I go to master, and I had this 8-second. These were the files that I had created by the weighted batch processing script. And this will kind of bring you up to date with where I am, with the exception of drizzle. Okay, well, still not done. All right, this is the high rejection for red, and I don't need that. This is the low rejection for red, and you can stretch that and see what pixels are hot. So this is the red 8-second exposure for the Andromeda Galaxy. This is going to be my star picture. Now, I renamed this, and I called this Red 8, meaning 8 seconds. And so I don't need it, but this is where it is. This is the same file. This is the Red 8 file. And you can see the band across the top where stacking artifacts happened. So we're going to put this back over, and we don't need it. We'll close it. And this is our green high rejection, low rejection, and so this is the green 8-second file, which matches this one because I just renamed it green 8. And so, and then this is the high rejection blue and low rejection blue. And there's not a lot of signal because there's only 55 of these, so it's not a lot of signal, but there's plenty for my stars. And and that coincides with, this is the exact same file, exact same blue file, so we're good. Now, I don't need this, and I don't need the rest of them, other than this is my 45-second red, and I'll stretch it and show you where we do have some more data. We went a little longer. And here's my 45-second red, and they are identical. So that's how I got these files. These are my original raw files. These are the same files. I just renamed them, and that's the work I've done so far. So I'm going to go ahead and delete these. We already have them, and we're not using them. We're going to use them for comparison. And so, because I know I'm extremely undersampled, my image scale with my rig gives me very pixelated stars when you zoom in on them. And I'll show you what I mean. Let's see, we had some good signal in green at 45. So let's just kind of move in on here and kind of zoom in, and I think you can see what I'm talking about. These stars are very pixelated. And so I went ahead and I ran drizzle. Now you remember in the weighted batch processing script, in order to have drizzle files, you've got to tick that drizzle box, which we had done. And by having done so, we've created some drizzle files, but they have yet to be processed. Now, because it takes a while to run drizzle on all your images, I just went ahead and did the drizzle. So this is a green 45-second. This is a drizzled green 45-second. So it's the exact same image, except this has been drizzled 2 times. So let's stretch it, and let's zoom in on these stars. And let's find some nice bright stars to compare and some dimmer ones. Okay, this is a nice bright star. Now let's drag this on top of the name, not on the bar, but on the name, and it will create an equivalent zoom, and so we can compare these stars. This one's been drizzled. This one hasn't. So this is the need for drizzling. It will have a very positive effect when you're undersampled on your stars. Now, it's my understanding now that if you have a one-shot colored camera, it doesn't really matter what your image scale is. You should drizzle. And the reason is that these stars on a one-shot color camera, just because of the optics, usually will have a green side and a red, a greenish blue side and a red, and kind of side to your star. And these kinds of color on your star are really just due to everything from dispersion to your optics. And if you drizzle, and now in the weighted batch processing script, you can separate your one-shot color camera images into R, G, and B and apply superpixel instead of V and G. And if you do that, and then when you recombine them, that red and green is no longer there. So it is recommended, and I've tried it, and it does work. In fact, I did a video on it in the last month. Not this month, but in the month of August. That if you scroll down, you'll see what I'm talking about. Okay, so this is our drizzled image and the one we're going to be working on today. And let's put that back. Let's just also keep, I'm going to keep the original as well, and then I saved this as a project. So first let's create our star image, but in order that we have geometry for all of our stars to be exact, the easiest way to do that now is now and not later. You can do it later by registering your images again, but let's just do this now. So let's go about right here on this loom channel. Actually, I don't want to use the loom because I really don't see any edge artifacts. Let's do one where we will, and this probably will show it. Yeah, there's some edge artifacts here, and I happen to know there's some at the top. So we're going to do a crop, and let's bring up our dynamic crop, and let's move it in about there. I don't want to cut out much. This is a wide field, but Andromeda is an enormous target. Okay, that's going to be my crop, and I'm going to create a process icon for my desktop, and I'm just going to drag this right here, and I'm going to go ahead and crop this. And so red has been done. Red has been done. So let's go to loom, and let's do loom. And I'm going to drag the process icon on the loom, and loom's now been done. Let's go to green, and let's drop on green. Now that's been done. And let's go to blue. Blue's the one that had the edge artifact. Let's make sure we got it enough of it, and let's drop that on blue. Yeah, we did get rid of it. That's good. And now let's go to our stars, because we're going to be adding the stars back to we have the red stars done. To our longer exposure image, to these when combined, we're going to add the smaller, tighter, less saturated stars. And we got rid of it up there. Good. And this is where we had the artifact at the top. See that line going across the top? So bingo. Now, just because crazy things happen, I'm going to go ahead and change this to dynamic crop, and I'm going to put this up here next to dynamic crop. And I just happen to know now, we can move these over. That if I am in need of I'm anal about these things. Okay, so if I need to drizzle this, if I destroyed the blue file or accidentally deleted it, there's no recovering. If you do that, then I will have my original crop that I can use if something nutsy happens. So it's just better to have it and not need it than to need it and not have it, as the old cliche goes. So let me show you how I ran Dizzle integration. I'm going to bring it up, and you can go to process, all process icons, and come down here to Drizzle integration. I save it as I use it often. Unless you have a one-shot color camera, the only thing you need to change in the default area is enable color filter array. If you have a one-shot color camera, you need to check this. I'm not using it, so bingo. And if you check color filter array, you may have to pick your barometrics. If you have a CMOS camera by ZWO, it's always LRGB. Some cameras write the barometrics pattern into the EXIF data, so it's part of the embedded file, and it can automatically be read, and you don't have to add you don't have to change auto. But to be on the safe side, you might as well, if you're doing a one-shot color camera, check this and then find your barometrics pattern, and manually you make that change. Okay, then I added the files, and in order to add the files, you're going to go to the folder where all your output was stored, which is PixInsight, and you'll go down to registered. And I'm going to start with the blue, and the files that are going to be relevant are the darker files. The irrelevant files you don't need, and so they remain grayed out. But these are your drizzled files, and it's easy to tell that they are because the XDRZ suffix has been added. So grab those, and you open those things up, and that's all you do now is just drag this to your desktop, and it will drizzle. I'm not going to take the time to do these, but when you drizzle, you're going to get two files. One's going to be all white. I have no idea what that is. Just delete it. The other is your drizzled image, and it will appear. This is the blue drizzled image, and this is the blue drizzled 8-second image. So it will be this image right here, the one that we drizzled. So no, it'll be this one right here. I'll move my files around, so it'll be this one right here. These are the non-drizzled original files. So these are going to be our working files. These were our original files. So we've drizzled. When you're finished drizzling this, you clear, you add files again, and this time you go and grab your, we did blue, now we're going to do green for 8 seconds. So grab those 20 files, load them, and then run it. And when you're done, you clear, add, and you go through all of those files until you've created your working files, all of which have been drizzled. So now that you have your drizzled file, let's see what we have. So I'm going to take RGB. I'm going to clear everything and restart it. And let's try first the 8-second. Thank God, how am I reading this? Okay, I got to reorganize. I see what I've done. All right, these are my working files. These, nope. Yes, these are my working files. These are my drizzled files. If it has a number by it, those are my original files. So now we got this straight. Yes, it gets confusing, and you can't combine. You can't interchange. No longer can you interchange this green for this green, because this green is twice the size, twice the file size, and it does take longer to process. So anyway, let's move these over so that we don't make the mistake of using them. And let's bring these back here. And now these are our working files. So let's look at our stars first. And we're going to put our red stars in the red channel. Just drag and drop our green stars in the green channel. And our blue stars in the blue channel. And let's run global. And so here's our stars. And let's change this to RGB, which means I'm only going to use this really for stars and this core because it's not blown out. But isn't it interesting how much actually even color and detail that you can pull out of an 8-second exposure? So let's bring our RGB stars over here. We'll be working with those independent of our longer exposure stars. So let's reset. Now let's bring our red and our green and our blue 45-second stars. We have RGB selected. Let's run it. And it failed. And why did it fail? We have our R. Let's reset it again. Our R and our G and our B. So let's run it. Let's check our R, our green, and our B. The only thing that I can think of is that when I cropped, we're going to have to look at this, is that I didn't crop one of them because the geometry's wrong. So let's go over here and let's put one on top. I don't think I cropped this one because look down here at the bottom. I'm going to gamble and I'm going to bring up my crop and I'm going to bring it over here. And I cropped it. Now let's bring it back. Another good reason to save crop if that is the case. And so I'm just curious. And let's just open these up exactly same size. One. Let's put one on top of the other. And then let's blink back and forth. Yep, that's what it was. I didn't crop one, so there's green and red, green and red, green and red. So that's a good reason to save your, by the way, I should have done that intentionally just to show you that it's a good idea to save your process. But let's see if this works now. Bingo. Okie dokie. That looks pretty typical. So we no longer need that. By the way, you can find RGB combined in your processes when you go up to Process, All Processes, and come down here to RGB. Is it called RGB combined? I'm not sure. That's what I call it. Channel combination. So it's not called RGB combined. So you find it by going to All Processes and Channel combination. Okay. We don't need it. Now, the next thing that I think I am going to do is, I want to show you something, by the way. If you bring up the screen transfer function and if you link the channels and stretch this, it's going to look funky. And so you may say, what in the heck have I done? So you want to unlink the channels to get a better picture of what you've gotten. But another way that you can approach that is by applying linear fit. So let's just delete this and let's go to Process, and we want to get to, let me see if I can find this. Oh, is it script? Wait a minute, it might be a script. No, it is a process. Image statistics. We want to bring up linear fit anyway, so it's bear with me. There's linear fit, and hang on, Snoopy, Snoopy, hang on. I don't think it's down this. Oh, it is. Okay, image statistics. Wow. Okay, let's load the red channel first. Not stars, just the red channel. Okay, and we want to see what the mean is. 3.502. Make a note of that. 3.502. Then we want to do the blue channel. We'll do the green, and that's 3.9. So the lowest one so far is 3.5. All right, now let's do the red, the blue channel, and that's 1 point. So the blue channel, we're going to fit to the rest of them. So that's what we're going to use. We're going to take the blue channel, and we're going to put the blue channel right there. Leave everything alone. Now let's bring up the green channel and apply a linear fit to that. We're just matching luminosity, so that so take it a second. It takes it a lot longer when you have drizzled your image. Prepare for some wait time. Okay, doesn't look good, so we're going to restretch it. Looks better. So we've done blue. It's already where it is. So now we got to do green. Oh, we did green. Now we have to do red. No, we just did red. So now we have to do green. I'm losing my mind. All right. Let's do the same thing. Okay. Now we have all three of them with the level of luminosity matched. We can get rid of that. I guess that's what you call it, levels of luminosity. When you first bring up your screen transfer function, which I got from going up to all processes, and you go down to screen transfer function. When you bring it up, it will be linked. And so when you apply the linked, and you link your channels to your image, your RGB image, then there may be more blue signal or green signal or red signal. When you're doing narrowband specifically, there's so much green, and usually you're doing the show palette, or you may be doing the show palette, so your image is green, that it just dominates because they're all linked. But the reality is you want to balance your channels. So linear fit, adjust all your channels so that you can. So now if you stretch, oh, we need to bury this. And now we need to bring up our RGB combine again. And let's just reset it for safe to do our drag and drop. And our blue. And we're going to run a new RGB channel. And let's stretch it now. Well, we still have, let's unstretch it. I took some little blue compared to the other two that it's getting a bias. Okay, but we have run linear fit on each one of them. I'm not even sure it did any good. Let's see. Next, we're going to probably a good place to go here. Let me see my noise. Not too bad, but we're going to let's go ahead and run the DBE, and I have a preset set that I borrowed from Sean Nielsen, which I think is a brilliant preset, particularly for galaxies where you really just want to set your references for background on the edges. I'm going to open this up, and I'm going to resize all, makes them a little bigger, and I'm going to drag them to the sides. So I went ahead and moved them to the edge, and then I added a couple further in where I see the gradient kind of changing. And I'm going to save this because I may run it several times. So I've saved this process, and I'm going to apply it. It's going to take a second. And so we'll restretch. And we'll delete it. We'll bring it back up again. This time we're going to select subtraction. We're going to run it again. We have to hit the execute. Subtraction is going to work on any vignetting in the corners. Division, subtraction is multiplicative, whereas your division is fighting light pollution and the gradients that are going across your image. Okay, I still have some green here. I'm going to add another here and another here, and I'm going to delete this process icon and make a new one, and we're going to run it again because I'm going to use the same one on the stars. I really don't have a background problem with the stars because I'm going to extract them, but it will have some effect on the color of the stars, I think. I do it on the safe side. Okay, that really helped, but let's go back to division, and let's run it again. Okay, that's just about as good as I'm going to be able to do on removing the gradient. There's still some there, but I'll work on that background independent of the stars when I extract the stars from both this one and I extract the stars from the star image as well. So at this stage, let's get rid of DBE, DBE, and we're going to change this identifier to, I'm just going to say DBE for M31, and I'm going to put it over where I keep DBE edges. Okay, so let's go in and look and see what our noise looks like. There's some great noise reduction tools. I happen to have them. Noise Exterminator is a good one. And since this is a linear image, we haven't stretched it yet permanently. If you wanted to run it now, you could. And I don't really want to, though. If I'm going to use Noise Exterminator, it's going to be after I have stretched it. But I do want to affect what noise I do have in this image now. And because I took really short exposures at 45 seconds and 30 seconds for the loom, I think all in all it's pretty safe to say that there's not and shouldn't be a lot of noise. But I am going to try to mitigate what noise I can see in there. So let's close this out, and I'm going to use what I call multilinear MLT denoise. This is my new name for it, MLT-denoise. And these are my settings. If you're interested in running it, you will want to make sure that you have the linear mask checked. And so I'm going to create a real-time preview, and I'm going to check linear mask, and I'm going to unstretch this image because we want to see this image unstretched, and we're building a mask right now, and the white part, anything that's colored in blue or dark, is being protected from noise reduction. The white part is going to have noise reduction applied. So there is going to be some noise reduction applied to my galaxy, and I don't want that. I want my galaxy to have some defining regions, particularly where you see the banding. So I'm going to take the amplification down, up some, and let's pause. Up was not the right way. We want to go down. Let's go down to about 30. and it's clocking up here. As long as it's clocking, we haven't arrived. Okay. I may go down to 25. Well, I may go down to, say, 28. I really don't want much of my galaxy protected by this. So we're clocking now. Okay. That's what we're going to use. So we're going to uncheck preview mask and let that stop clocking. Okay, we can get rid of our real-time preview. We kind of know what our mask is going to look like. We can go ahead and restretch it, although there's no need to do that. And let's go ahead, let's zoom in and see. This is what it looks like now. And let's see the effect of this noise reduction when we drag the process onto our target. Okay. Now we have applied it. Let's see what it looks like before. And after. Before. After. And my stars are looking just fine. I may have gone just a little bit too far on those stars with my mask, but I'm going to get rid of those stars anyway and add the other stars back. But had I not shot for the stars, I might redo this and go back and have my mask include more of the stars. Let's make sure we didn't muck up our detail here. So let's go even closer because I really want some. It doesn't look too bad, but let's see. Yeah, a little bit. I think I can resurrect that, but it's looking before. There's a little, you just see noise gives it some contrast. And when you mitigate the noise, you do lose some of your contrast. So I probably should have gone from 28 to 20 on my right here on my amplification of my mask. And so as a matter of fact, let's do that. Let's go back, and I don't need to preview it. I'm just going to go down to 20. And we're going to run this. You know what I'm doing. I'm so dyslexic. Well, you're seeing screw ups. This is before. And here's after. Before. After. That's better. And we're going to leave it at that. We still have some structure. We have mitigated some noise. It's kind of, my gradient looks a little worse. But again, I'm going to remove the stars and I can fix the gradient when that happens. As long as the gradient isn't mucking up the subject really of this is this galaxy, and I can't see a gradient effect that's too bad here. I've been thinking something about linear fit that's really bugging me, and I'm not going to go back and make the changes, but I took 100 45-second reds, 100 45-second greens, and only 55 45-second blues. And in linear fit, the blue had the lowest value, and that's what I expected, but I wanted to see what the mean was for it. And then I tried to adapt the red and the greens levels of of value, channel value, to blue. And I just don't think it could have been done. So I'm not sure I'm absolutely right on point on this, but I don't think it even makes any difference. You're probably better off not running linear fit unless you know going in that your channels have about the same amount of exposure time. Now, I could have used the one with the highest exposure, which I think was red, or green at 3.9 with a 2 exponent, and I could have tried to have brought the blue up, but I'm thinking I'd create some artifacts doing that on the blue. So it's probably better not to run linear fit. In fact, it's one step you can probably leave out altogether. But I wanted to show you that, and it didn't work, that the channels can be adjusted to linear fit so that this, whether you have them linked or not, doesn't make any difference. The stretch will just reveal the images it should be revealed. Okay, now more on noise reduction. I don't think I'm going to run any more noise reduction at all on this image because I'm okay. The background's going to be worked on without stars, so I don't think I'll need the noise exterminator. I think 2 applications of noise reduction. One as strong as multilinear transform, or my MLT denoise, and the noise exterminator is too much, and it gets too plastic looking. The background and everything gets too plastic looking. So as a rule, I might go into the background and run background neutralization, but I really don't see a need to do that. I see still some color noise, and that isn't going to be affected by background neutralization. But let's go ahead and run it. It's not going to hurt anything. And to run it, we need to find background where there isn't any stars. So it doesn't have to be a big swath of the sky, but I'm going to go up here and grab the preview icon and just let's move it up to about there, and we can come out a little lot more, and then we're going to go to our background neutralization, and let's find that preview. So we're going to open up, and we need image 38, which is what this is, preview. It's the only preview, so it's easy to find. And let's run background neutralization. Let's restretch. Might be a little noisier, but don't pay any attention to it. It is, but don't pay any attention to it. It's because of the stretch. Okay. Everything's looking copacetic. We can get rid of the preview. We do not need it. So you can go up here to this red X on the preview icon and click it, and it's gone. You can also go to preview and delete preview. There's none to delete though. So now we're ready to color calibrate, and there's a number of ways to do that. I'm going to use Photometric Calibration, which can be found along with background neutralization. Here's background neutralization, and here's Photometric Calibration. When you bring up Photometric Calibration, you're going to see the need to either add catalogs to your astrometry and your photometry. And to find these catalogs, you need to go to the PixInsight page, their website for PixInsight. Go to the download section, and there's suggestions on what catalogs that you'll need. You don't need to download them all, but I would get Gaia DR2, and I would get the APA with the DR9, and those are the catalogs that will cover most of the sky once you've entered the right RA and dec. Now, what is the right RA and dec for this image? Well, it's Andromeda, and you can do a couple of things. You can search coordinates, and by that you can say type in M31 and search, and it's found them, and you can say get, and so it will populate the RA and dec with M31, or you can acquire from the image. Now, this image has already had so many tweaks to it that I don't think the RA and dec information is embedded, but you can go up to the FITS header and you can look through it and see if there's any RA and dec information, and I doubt that there is. It's all been wiped out as we've been processing this image. So what you can do, if you really want to get the exact size and scope and so forth and angle of Andromeda, you can go to the File, Open, and pick up one of your subs that you used. So we would need a light frame, and any light frame would do. It doesn't have to be an 8-second or a 45-second. So here's our light frame. Take note of what the RA and the dec is, because there will be a change, and then here you select Acquire from Image, and there was a slight change. So what we have from this image is RA, dec, start time, we have the instrument focal length, and we have the pixel size. So that's been provided. But you know we have a problem. This is the same image, but this image is twice the size. So what we're going to have to do is change the focal length, and we're going to change it to 840. No, we're not. This is a 420 telescope with a reducer. So it's 336 times 2. So we're going to go 672 is going to be our focal length. We keep the image scale the same. The rest of the settings would stay the same. And we're going to apply. It's going to take it a few minutes to run, so I'm going to see you later. Okay, it has done its magic, and I'm going to try to explain how this works. There's several ways to do color calibration, but the goal really is to establish a black point and a white point reference, and then calibrate all of your stars based on your dark point and your white point. If you use the color calibration script found under processes, all processes, color calibration, you can set a white reference. Some people use the entire image, or you can zoom in on what you think is a white star. That's the operative word. You're picking a white star. You might think this is the white star. And it might be, but it might not be. And so then you have to take a part of the sky, kind of like we did for background neutralization, and load that in order to color balance. There are also some scripts. There's a very good script called AutoColor, and I think Bornman created AutoColor. It may be under Render, no, script, and there it is. And it works pretty well. It may even be considered very well, but personally I am a fan of Photometric Calibration, because what it does, it takes first it takes astrometry, and it plate solves, and so it knows exactly what it's looking at, your image, using your RA and dec coordinates and the time you took it with the telescope and image scale. And then it uses photometry, which is to it knows what the white stars are. You're not guessing. And it is going to apply the right color based on the stars it knows should be on the white side to be used. So I can't think it could be any more accurate than that. And so for that reason, I lean towards using photometric calibration. It takes a little longer, but I think it's the way to go. We are now ready to just about end this first part of this processing step by running a histogram transformation, because we are ready to stretch this image. I'm going to change the name, and I'm going to call this one RGB, and this one's going to also it's had several things applied to it, but we're just going to call it linear. And it's the image right prior to stretching with all the tweaks that we made. And I'm going to make a clone of it. And we're going to set the clone over there. And actually, we're going to save this image. We're going to make another clone. And we're going to run the histogram transformation twice. We're going to stretch this using not a new script, but it is a easy processing suite script where you have a way of stretching using the easy soft stretch. So give it a shot. It brings up this window that shows you what it's going to look like once it's stretched. And you can make some changes. For one, haven't even tried because I don't use this, but we can run it. So it has been stretched by the easy. Let's go ahead and call this NonLinear and easy stretch. So I'm not using it, so we're going to just go ahead and put it in a place where we can come back and revisit. We're going to unstretch this, and I'm going to bring up the Histogram Transformation tool. And you can bring up the histogram transformation by going Process, All Processes, and come down here to H's. Histogram Transformation. There she blows. And I'm going to put on a real-time preview. As a matter of fact, let's make 2 copies of this. I'll show you 2 ways to do this too. And so we have a clone. We're going to work on histogram transformation twice. Besides easy, and there's another way you can do it too by masking. So let's bring up histogram transformation again, and let's make a real-time preview, and let's reset it. And so we're going to take the middle slider here, and we're going to drag it towards the middle, and we're going to apply a modest change. We're going to reset again. We're going to move this towards the middle some more, and we're going to apply. We're going to make incremental and gradual adjustments to get to where we want to be. Let's reset, and let's bring this over again some more. We need to also put we'll do this all over again because I made a slight boo-boo. It's okay. It's making the adjustments, but it's created a problem. We're going to make another. Just delete this. This is our non-stretched image. We're going to make another clone. We got clone, clone, clone. All right. Now this is clone, clone. All right. So we're going to bring up Histogram Transformation. Where it says no view selected, we want to see what we're doing. So we're going to put in clone, clone. So now we have this image. We're going to make a real-time preview. And now we're going to drag this over, just like we did before. We're going to tap it. We're going to reset. We're going to bring it over. And now you're seeing, because I've loaded the image, the stretching is showing the histogram moving to the right up here. All right, let's restretch. Let's move our dark point over a little bit, and then let's bring our right point back. Our middle slider. Let's apply. Let's restretch. And let's, we don't want to clip anything, but let's bring this over to the point where I'm looking up here, where we want to, if we're going to clip anything, we're going to be clipping over here on this side. It's going to be our bright stars. I'm going to add the stars back from my star image. Okay, let's apply this. We're almost done. Okay, let's reset. That's looking pretty promising. And we'll settle on that. So I'm going to close this out, and I'm going to rename this RGB. We haven't added any luminance to it, and it's RGB non-linear. So we know we have, and this is really what I'll more than likely go with. But I want to show you something else that you can do with the histogram transformation. Let's bring it up, and let's reset. Let's make sure we have our image in here, and it's clone, clone, clone. And so what we're going to do is we're going to stretch this image up here with the histogram transformation. And we're going to take this process icon, and I'm going to come down here and drop it. So that kind of looks like my stretch. Now we're going to unstretch it and just drop this over here. Okay, and it's stretched. It's kind of fast, and it probably got to the same place that I'm at right now, but if you look at my stretch and their stretch, mine's got a green color cast to it. We'll work on that. This looks awfully good. I like my background here a little better. I think I'm going to go with mine. When I say mine, the first manual stretch, but we're going to save this as RGB, and we're going to just call this a non-linear auto stretch, and we'll know what we did with this one. And so let's over here and add this to our pile of progression. And right now we're going to end this video having taken our RGB image from nonlinear, from linear to nonlinear, applying, after combining, applying a dynamic crop to all of them, but dynamic background extraction. We did some noise reduction, and we did some background neutralization, and then we did color calibration with photometric calibration, and then we ran the histogram transformation. So that's where we are so far, and we're going to start on a second video where we're going to work on the luminosity mask. It won't be nearly as long, and that will be part 2. So this is part 1, and then we're going to do a part 3 where we work on our stars, and we take our stars through colorimetric calibration, and then we extract the stars, and we will save those stars to be added back when we're finished with our the tweaks that we're going to make on our RGB image. Once we've added the luminosity to it, we'll add our stars back, and we'll extract the stars in that image and add the stars from the star image. I think that makes sense, but at any rate, I will see you on the next video, and for the rest of the day here, have a good one.